Fine, fine. What happens if you're in an airplane moving the speed of light and then you start running in it? First of all, an airplane cannot go the speed of light. It just can't. You can't get mass moving the speed of light. So instead, I'm going to assume that you mean an airplane moving very, very close to the speed of light. And then you start running in it, so you would be moving faster than the airplane. Wouldn't that mean that you're moving faster than light? Well, no. Because in your everyday life, when we add velocities together, we do just that. We add the velocity of one thing to the velocity of the other thing, and then we get their combined velocity. And on our everyday life, that works. The real equation for adding velocities is this. V is one velocity, u dash is another velocity. Now this term over here is one velocity times the other velocity divided by the speed of light squared. And at small velocities, that's going to be almost nothing. Meaning this whole bottom term is very, very close to 1, which means that this whole thing would simplify to one velocity plus the other velocity, which is what we do in our normal life. But when you are moving close to the speed of light, this term gets bigger, which means that your velocities don't just add up neatly anymore. Instead, you're only getting a fraction of each one when you add them together. This also mathematically shows why you can't move faster than light. Because if those two velocities added up to more than light speed, then eventually you're going to see a very strange mathematical thing happen. You're going to see this bottom term get bigger and bigger, and eventually adding your velocities is going to make you slower than you originally started. It doesn't make any sense. In fact, you can see the limit when you plug in the speed of light here. Let's say one velocity was the speed of light and the other velocity was the speed of light. So you're trying to move twice as fast as the speed of light. This whole thing is the speed of light squared divided by the speed of light squared, which is 1. So it's 1 plus 1. And this up here is the speed of light plus the speed of light, or 2 times the speed of light. So it's 2 times the speed of light divided by 2, which is just the speed of light. Which means if you took something that was moving the speed of light and you added the speed of light to it, it would still only move the speed of light. There's your hard barrier right there.